All right, everyone. So this is going to be the second SAT review video. Um, so these problems are different versions of problems that are similar to some of the ones on the practice assessment you guys took all those months ago. Okay, so this was similar to a question we saw. In the xy plane, if the parabola with the equation y equals ax squared plus bx plus c, where a, b, and c are constants, passes through 1 comma negative 1, what would be true? So this is a really complicated looking question that isn't actually as difficult as it sounds. So parabola, if you're not familiar with that word, that's just kind of like a U-shaped graph, either going up or down. You'll learn more about it in your sophomore year. But here's what we want to do. We want to take this ordered pair with our x and our y values and substitute these two numbers, x equals 1, y equals negative 1, into the equation and see which one of these are true. So y is negative 1 equals a, x will be positive 1 squared plus b times x, once again positive 1, plus c. And then simplify down and just look to the list which one of this, after we simplify it down, can algebraically match up to one of those. So negative 1, nothing I can do with that. 1 squared is 1, 1 times a is a, 1 times b is b, and c. It's by itself. So here is a simplified version of this equation, and we just need to see, well, which one of these is true. So if I had, this first one has b plus c on one side, so how would I get b plus c alone? I would subtract a from both sides. That is a positive a, so that is not it. I'd have negative a minus 1 equals b plus c, so that's not true. Let's see. This one looks promising. If I just add 1 to both sides, I get 0 equals a plus b plus c plus 1, and that one that's true. A plus b plus c equals negative 1, so if I had a minus b on one side, that wouldn't even happen. A and b have the same sign when they're on the same side of the equal sign, so that one's not true. And what about this one? This one also looks maybe. Oh, wait a minute. No, look. A plus b plus c equals negative 1, not positive 1, so that one's not good either. Looks like it's just that one. There's a problem just like this on the SAT assessment. So just remember that the ordered pair is x comma y, and you can substitute x comma y in to whatever expression they give you and simplify it down and see what's what. All right, this next question is very, very close to one of the questions on the SAT practice. I just changed the numbers up a little bit. Which of the following is equivalent to this expression here? Now, normally when we distribute, we have the single term first and the minus or plus term second. But it doesn't matter if the minus or plus term is first. We're still going to distribute. So a times a over b minus b times a over b when we distribute. And now we can simplify a little. So a can be thought of as a times 1. So a times a over 1 times b is a squared over b. And then my next term here, minus, b can be thought of as b over 1. So I have negative ab over b. Well, negative ab over b, we can factor b's out, and that's just negative a. So a squared minus b minus a. It's got to be that one. So don't be scared about distributing. Even if the single term is second, you just distribute as if it were first. And remember, with multiplying fractions by whole numbers, you can think of whole numbers as themselves over 1 times the fraction. So So there's a couple hints there. This one is very, very similar to a question on the practice assessment. I changed the numbers a little bit, but pretty much copied word for word the question, just changed the numbers a little bit. Okay, so they give you some equation here that is, in this case, modeling the number of cups of hot chocolate sold per day at a coffee shop, and depending on the average temperature of that day. So N, the number of coffee cups, hot chocolate, sorry, not coffee, hot chocolate. N is equal to some big number minus 3T, where T is degrees in Fahrenheit, N is the number of cups of hot chocolate, and the question is, according to this model, what is the meaning of 3 in this equation? So, to me, it sort of intuitively makes sense. I don't know how to explain intuition, so I'll explain trial and error, which I normally don't do, but in a multiple choice questions, trial and error is okay. Maybe not exactly trial and error, but let's quickly read all these options. For each 3-degree increase, 1 more hot chocolate sold. For a 3-degree decrease, 1 more hot chocolate sold. For a 1-degree increase, 3 more cups sold. For 1 Fahrenheit degree decrease, 3 more cups sold. So something is happening here. The temperature changes, the amount of coffee cups change. This sign indicates that they're not changing in the same direction. Like if this was a positive, then the N and the T would both be changing in the same direction. But because this is negative, they're not changing in the same direction. So the increase more, C and A, these are probably not going to be the choices based just on that sign. We could use a little common sense. Obviously, if the temperature gets hotter, we don't necessarily sell more hot beverages. We usually sell more cold beverages as the temperature goes up. So this one feels suspicious, but we're not sure. All right, so it feels like D is correct, but let's do a little messing around and make sure. Let's pick a couple of real easy numbers, all right? Let's pretend it's 10 degrees and 100 degrees. I know these are really unrealistic numbers, but just to get a real basic idea. This was a question, by the way, from the no calculators section, so I'm going to choose some big numbers. So let's say T equals 10 and T equals 100. What would N equal when T equals 10? What will N equal when T equals 100? So 567 minus, all right, if T equals 10 minus 30, so that would be 537, where if it was 100 degrees, would be minusing 300, and we would look at 267. So, hey kids, I'm in the middle of recording a video. Can you give me 3 minutes? Thanks, guys. Sorry about that. So, very quickly, our suspicions were correct. As temperature gets bigger, number of hot chocolate sold gets smaller.
We'll be at the library.
Okay, I'll be down in a minute. Sorry, guys. So let's quickly maybe with T equals 10, maybe T equals 11 will give us a little insight here. So when T equals 11, what is N going to equal? We're going to take 567 minus 33, and that would be 534. So this is a real good hint to what's going on right here. It looks like as temperature goes up, the number of coffee sales go down. Another way of looking at that, if we start really here and work our way backwards, as temperature goes down, number of hot chocolates go up. If the temperature goes down by 1 degree, from 11 degrees to 10 degrees, the number of hot chocolates increases by 3. each degree the temperature decreases, 3 more cups of hot chocolate are sold. So, logic, reasoning, a little bit of trial and error, I guess. But yeah, lots of strategies for SAT stuff. So, this will be good just over 10 minutes, 10 and a half minutes. This will be good for video number 2.